I kind of got this all set up. We're going to look at how to solve for X and Y for piecewise. I've already got E kind of set up. I rewrote like basically our domains for each piece. So where it says 0 to 6, right? I can write that in interval notation like this. The set notation, most people find more complicated. And you're right. You made a good point down here. That one looks funny. This does actually mean that. It means starting at 12, but going on infinitely in that direction. Okay, you kind of just say x is greater than or equal to 12. So it's basically including 12 and then all the way to infinity. But I would agree with you guys that this makes more sense, like logically to my brain, than the set notation does, where it's just like a number. You kind of think like that's like sort of the end of it. Well, no, it's actually the beginning, and saying go to infinity, it just doesn't write it, which is kind of annoying. That's a great question. So the difference here is that on these guys, because that one here doesn't have an equal to sign and this one does, when I went to go write the interval notation, the fact that these brackets are facing away basically means that I am not going to include it. Go away. There you go. Right? It means I'm not including 12. I'm going right up to it, but not including it, which is kind of annoying. But again, this is where I say interval notation, right, is easier to understand because you just basically see where the bracket's hugging the number. If they're facing away from it, then I'm going to ignore that one and then use the one where it is being hugged. So when it asks here, and this is a good first one to look at, what is the height of the balloon at 6 seconds? Well, I see 6 here and I see it here. But the difference is this one, the brackets are facing away. This one, it is hugging it. So if that's the case for this guy here, what is the y value when x is equal to 6? Well, the piece I am going to choose is the second piece. So piece, I'm gonna write it out. So plug in to piece 2, which was y is equal to 7x minus 24. So I'm plugging in x is equal to 6 there. Stop doing that. Y is equal to 7 times 6 minus 24. So I chose the piece I wanted to plug it into. We're now going to have y is equal to 42 minus 24. So in that case, I'm going to end up with, nice. Okay. So that's the value for that guy right there. Question, Bradley?
I just have a question. Can you like divide 18 by 6 and then figure out how much it goes up per second, or would that not work because the different functions?
The different ones are going to make it so that like if you go to another piece, that's not going to follow the same pattern anymore. Yeah. But again, the hardest part of solving for a y value is that I've got to choose the proper piece first, this guy here, before I can actually go ahead and do any work. Whereas now let's skip down and take a look at what we have to do when we have G here. Okay? How long will it take the balloon to reach a height of 12 meters? So for G, find X in piecewise. So this is the other example. Instead of choosing, basically what I want you to do is trial and error. And you have to use all pieces, which is kind of annoying. So when I say trial and error, what it means is, and I'll just say this quick, and if it doesn't make sense, we'll walk through it. When I plug in y is 12 and solve for an x, if in the first piece I plug in a y of 12, and my answer is falling outside of the domain of 0 and 6, then I reject that as an answer. If the answer does fall in between 0 and 6, then I can't accept it. So let's look at that. So we'll plug it into piece 1. Y is equal to 3x. and I'm going to plug in a y of 12 and then just solve. Well, x is equal to 4. Does that fit between 0 and 6? Yes, it does. So we will accept that answer. So if the answer falls between the domain of that piece, then we accept it.
I don't have a question about G. I would have to work
Let me finish this
already.
and I'll go into it. So piece number 2, we are going to use that y is equal to 7x minus 24. We're going to plug in 12. 7x minus 24. Bring that over. We're going to be adding 24 to it. So I'm going to have 36 is equal to 7x. And then whatever 36 divided by 7 is. So x is equal to 5.14, blah, blah, blah. Now, that piece, the domain of it, was between 6 and 12. So on this guy, did 4 fit between 0 and 6? Yes, it did, so I accepted it. Does 5.14 fit between 6 and 12? It does not. So on this one, we will reject it as an answer. So that one doesn't count. But it's kind of annoying that I had to go through that whole process just to see if it did fit. Now, the third one is the one that'll likely trip you up the most, okay? But you see where it says 60? Well, it's saying y is equal to 60. There is nowhere, or I wouldn't say that, there's nowhere to solve for x, but essentially when I plug in 12 is equal to 60, those do not match. So we can reject that one as well. The only way you would accept that one is if it was like 60 is equal to 60. And that just doesn't work as a thing. So to go back to it, solving for y, we choose a piece and plug it in and solve. The solving for an x, we kind of trial and error our way through it, plug in a y and solve for an x, and you can accept more than one, but in this case we only accepted this one right here, and then that was it. But you kind of have to keep going because sometimes it may include both of them.